Hello everyone, my name is Terry Chang and today I'm going to introduce find multiples and factors. So the first thing we will learn in this section is to identify multiples of 2, 5, and 10. So for example, Annie is counting the shoes in her closet. The shoes are matched in pairs, so she doesn't have to count each one. She counts by twos. 2, 4, 6, 8, 10, 12. She has 12 shoes in her closet. The numbers 2, 4, 6, 8, 10, 12 are called multiples of 2. Multiples of 2 can be written as the product of a counting number and 2. So on the right there is a list of the first 6 multiples of 2. 1 times 2 is 2, 2, 2, 4, 3, 2, 6, 4, 2, 8, 5, 2, 10, and 6, 2, 12. The multiple of a number is the product of the number and the counting number. So a multiple of 3 will be the product of a counting number and the 3. It's not below, it's on the right there is a list of the first 6 multiples of 3. 1 is 3, 2 is 3, 6, 1 is 3 is 3, 9, 4 is 3, 12, 5 is 3, 15, 6 is 3, 18. And here is the list of the multiples 2 to 9 from 1 to 12. You can just remember this. It's like 1 times 2 is 2, 2 times 2 is 4, 3 times 3 is 9, 3 times 2 is 6, 4 times 4 is 16, 20, 24, just you can remember this. This shows the counting number from 1 to 50. Multiples of 2 are highlighted. Did you notice the pattern? So the last digit of each highlighted number in the table above is either 0, 2, 4, 6, or 8. This is true for the products of 2 and any counting number. So to tell if any number is a multiple of 2, look at the last digits. If it's 2 or 4 or 6, 8, or 0, then the number is a multiple of 2. Now you can try to determine whether each of the following is a multiple of 2. 489 and 3714. For this one, I'll give you 30 seconds to answer it. Okay, the answer is no and yes. So we just select to find the multiple of 2 we see at the last digit. For 89, 9 is not the multiple of 2. We say it's 0, 2, 4, 8, and 0, 2, 4, and 8, and 6. So 9 is neither the answer and 4 is the answer. So next, to determine whether each number is a multiple of 2. For this one, just give you 10 seconds because you just practiced the last one. Okay, the answer is yes and no, so we just look at the last digits, 8, and this one will be 3. And next one, to determine whether each number is a multiple of 5. This one, again, I will just give you 20 seconds to answer it. The answer is yes and no. So we said the multiple of 5 will have the last digit of 0 and 5. So 675 will be the multiple of 5. But 1578 will not be the multiple of 5. Next, determine whether each number is a multiple of 10. For this one, I'll just give you the answer is yes and no. So we know to determine which number is a multiple of 10, we just look at the last digit. If it's 0, then it's multiple of 10, and if it's not, then it's not. So 680, we get the 0 for last digit. Next, to identify multiples of 3. It might be a little different with 2 or 5 or 10. So for the multiple of 3, we don't look at the last digit. We look at the sum of the digits. So for example, 12. It's 1 plus 2, which is 3, and 3 is the multiple of 3. For 24, it's 2 plus 4, which is 6, and 6 is the multiple of 3. 36 is 9. It's also a multiple of 3. So consider the number 42, because we know that 24 is a multiple of 3, because 2 plus 4 is 6. So 42 is 4 plus 2, which is also 6. It's also the multiple of 3. So we know that 42 is also a multiple of 3. You can look at 18, it's 9. 48, it's 12. 39 is also 12. 45 is 9. 42 is 6. So for the sum of digits, if it is 3, 6, or 9, it will be the multiple of 3. Okay, so now you can try to determine whether each of the given number is a multiple of 3. 645 and 10,519. For this one, I'll give you 40 seconds to answer it. Okay, the answer is yes, because for the first one, it's yes, because 6 plus 5 plus 4 equals 15, and 15 is 3 times 5, so it's a multiple of 3. And for the second one is no, because 1 plus 5 plus 1 plus 9 is 16, and 16 is not the multiple of 3. Next, use common divisibility test. Another way to say that 375 is a multiple of 5 is to say that 375 is divisible by 5. In fact, 375 divided 5 is 75. So that 375 is 5 times 75. If a number n is a multiple of n, then we say that n is divisible by n. Since multiplication and division are inverse operations, the patterns of multiples that we found can be used as divisibility test. Table below summarize divisibility test for some of the counting numbers between 1 and 10. So a number is divisible by 2 if the last digit is 0, 2, 4, 6, or 8. A number is divisible by 3 if the sum of the digits is divisible by 3, which is like 3, 6, 9, 15, 12, 18, 21. Then for 5, if the last digit is 5 or 0. 6 if it is divisible by both 2 and 3, and it's 10 if the last digit is 0. So now you can try to determine whether 1290 is divisible by 2, 3, 5, or 10. For this one, you have to write down 4 answers, for 2, for 3, for 5, and for 10. I'll give you like 40 seconds to answer it. Okay, the answer is for 2 is yes, 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 and yes. So we can see 1290 is multiple of 2 because the last digit is 0. And for 3, 1 plus 9 plus 2 is 12, which is also a multiple of 3. And for 5, the last digit is 0. For 10, the last digit is 0. Next, find all the factors of a number. In the expression a times b, both a and b are called factors. If a times b equal m and both a and b are integers, then a and b are factors of m and m is the product of a and b. So x times 9 equals 72. X times 9 is the factors, and 72 is the product. We can find all the factors of any counting number by systematically dividing the number by each counting number. Starting with 1, if the quotient is also a counting number, then the divisor and the quotient are factors of the number. We can stop when the quotient becomes smaller than the divisor. So find all the factors of a counting number. Step 1, we divide the number by each of the counting number in order until the quotient is smaller than the divisor. So if it is a counting number, the divisor and quotient are a pair of factors. If it is not a counting number, then divisor is not a factor. And you list all the factor pairs and write all the factor in orders from smallest to largest. Next, identify prime and composite numbers. Some numbers like 72 have many factors. Other numbers such as 7 have only 2 factors, 1 and the number itself, 7. A number with only 2 factors is called a prime number. A number with more than 2 factors is called a composite number. The number 1 is neither prime nor composite. It has only 1 factor itself. So you can see here, a prime number is a counting number greater than 1 whose only factor are 1 and itself. A composite number is a counting number that is not prime. In order to determine whether a number is composite or a prime number, we need to see if the number has any factor other than 1 in itself. So to do this, we can test each of the smaller prime numbers in order to see if it is a factor of the number. So the number 2 have factors 1 and 2, which is 1 in itself, so it's prime. 3 is 1 and 3, so it's prime. 4, it can be 1 times 2, it can be 2 times 2 or 1 times 5. 1 times 4, so it will be composite. So same how to determine if a number is prime, you just see if the factor is 1 or itself. Thank you for listening.